Hi, this is Miss Townsend. Let's solve this grade 10 question together. It says solve the system of equations given below. So equation number 1 is written 3x plus 5y minus 12 equals 0. So that's in standard form. And equation number 2, also in standard form, 2x minus 4y plus 3 equals 0. So when I'm given two equations in standard form, what I like to do is solve by elimination. In order to solve by elimination, I need either my x terms to have the same coefficient, which they currently don't, but I could make them both say 6x pretty easily. Or another option is I need to make the y terms have the same coefficient, which they currently don't. I could make them both say 20. So there isn't really an advantage to necessarily doing one or the other, but there is a slight advantage to making the y's have the same coefficient, because because I have positive 5y and then I have negative 4y. That means I'll be able to solve by elimination by adding the equations. Whereas with the x's, if I made them both 6x, they would both be positive 6x, and then I'd have to subtract the equations. And it's just a fact of math that we're more likely to make mistakes subtracting than adding. So I'm going to make both of my equations have a 20 in front of the y. So that means equation number 1, to make this a 20, I need to multiply the entire equation by 4. So it's the y that I want to change, but I have to follow the rules of math. The entire equation has to be multiplied by 4, or I can't multiply by 4. So I'm going to do that. 4 times 3x is 12x. 4 times 5y is positive 20y. And 4 times negative 12 is negative 48 equals 0. 4 times 0, 0. And now I'm going to take the second equation and I'm going to multiply by 5 because I want this to say 20y. So 5 times equation 2. So 5 times 2x is 10x. 5 times negative 4y is negative 20y. 5 times 3 is positive 15. And of course 5 times 0 is 0. So I have equivalent equations. They're the same equations technically. I've just increased them by multiplication. And now what I can do is I can add these equations together. When I add them together, what happens here with the y value is I have positive 20y plus negative 20y is 20 minus 20, which is 0, which means I'll have eliminated the y term. So what I really need to do is focus on what else happens in the equation. So with the x's, I have 12x plus 10x, that's 22. 22x. And I'm not even going to write that. Negative 48 plus 15. So this is why I like adding, because it's easy to forget if you were supposed to be subtracting. So negative 48 plus 15 is negative 33 equals 0. And now I have, and I'll just rewrite it so it looks a little nicer, just one equation and only one unknown variable in it. So I can solve for x. Oops, and I wrote that as 2 instead of 22. There we go. So 22x would be equal to 33. So x is equal to 33 over 22, which reduces to divide both sides by 11. So that reduces to 3 over 2. So I know what my x value is, and now I need to go back and find my y value. And to do that, I'm going to sub x equals 3 over 2 into one of these equations. I'm going to sub it into the second equation because I like multiplying by 4. If I have x equals 3 over 2, I like the fact that I'm about to multiply by 4. That's why I picked it. Doesn't matter. So 2x, oh no, I know what x is. Sorry. 2x minus 4y plus 3 equals 0. And of course, we just discovered that x is 3 over 2. So now I can solve for y. So that's 6 divided by 2. So 6 divided by 2 is just 3 minus 4y plus 3 equals 0. So collecting like terms, 3 plus 3 is 6. So I have negative 4y plus 6 equals 0. So I'm solving for y. Negative 4y equals negative 6. So y is negative 6 divided by negative 4. So I need to reduce that fraction. So it becomes a positive y equals 3 over 2. So I now know that the solution to the system is 3 over 2, 3 over 2. So that's just a point on the Cartesian plane. Thanks for watching. Keep doing math.